We're going to solve weekly review number 6 for the class Algebra 1, Algebra 2, Integrated Math 2. Problem number 1 says evaluate the expression for the given values. What we are going to do is just substitute those x and y values and then use order of operations to get the solution. It's not an equation because I cannot see any equal sign in the whole expression. It's just an algebraic expression. So what I'm going to do is to start by substituting those numbers. So 3y, what is the value of y? 5. So 3 times 5 plus 14 minus 2 parentheses 2 times x, but in this case x is equals to 3 plus 8 minus 4 times x times y. We know that x is 3 and y is 5. So all the substitution is done. Now I'm just going to do order of operation, multiply the numbers that needs to be multiplied. 3 times 5 is 15 plus 14 minus 2 times 3 is 6 plus 8 minus. Okay, then I have 4 times 3 times 5. I usually like to go for the easy number, right? 4 times 5 is 20 times 3 is 60. You can just do 4 times 3 and then that is all multiplied by 5 and you will get your values. Then remember, we have parentheses. We solve what is inside the parentheses. I have 6 plus 8 is 14. I rewrite everything. 15 plus 14 minus 2 times 14 minus 60. And then multiply 2 times 14 or negative 2 times 14, which is negative 28. 15 plus 14 minus 28 minus 60. I'm going to add 15 and 14 and negative 28 minus 60. Those are the numbers with the same sign. 2 positives, 2 negatives, we add them together. So 15 plus 14 is 29. And negative 28 minus 60 is negative 88. So 29 minus 88 is equals to negative 59. And that's the solution that we have for problem number 1. As you can see, 29 minus 88, my solution is negative because the negative number is bigger. So the absolute value is bigger in the negative side. So I will do 88 minus 29, but my answer is going to be negative. Now here, observe, is solving for y. We need to leave the variable y alone. So cover your variable. I only see that I only have y in the left side. So cover your variable, get rid of 4. So I have plus 4 both sides of the equation. Plus 4. Okay. 4 goes away. So I have 12y equals to 24x plus 19. Okay. What is the next step? 12 is multiplying my variable y. 12 is multiplying, so the opposite of multiplication is division. So we are going to divide both sides by 12. Every single element of your equation. So divide by 12, divide by 12. So 12 divided by 12 is 1. That's the reason why we said 12 goes away. So I have y is equals to 24 divided by 12 is 2x. And then 19 over 12, you cannot simplify it. So we will leave it as a fraction. Plus 19 over 12. And sometimes Alex asks you to round to the nearest hundreds or tens or thousands. So if you do 19 divided by 12, you will have something like y equals to 2x plus 1.58 if I round to the nearest hundredth, which is usually what Alex mostly asks on when you're solving your topic. So any of these two solutions are correct, so we just solve for y. Okay, let's move to problem number 3. Find the value of x in the following equation. See, we have an equal sign, same as this problem, so we're going to solve for x. I see parentheses, distributive property, number 1. There is nothing we can do. We need to start with distributive property. Negative 3 times 2, negative 3 times 3. So I have 5x. Negative 3 times 2 is negative 6. Negative 3 times 3 is negative 9. X equals to 7x. I can see that in my left side I have 5x and negative 9x. They are like terms, so I can simplify them. So I will do negative 6. That's the number that I'm not touching right now. So 5 minus 9 is equals to negative 4x equals to 7x. I can see that the positive number is on the right side. So I'm going to move this negative 4x to the other side of the equal sign. But remember, if we move that negative number, it goes positive on the other side, because the only way to get rid of this negative 4 is by adding 4x plus 4x. Okay, we are getting rid of this 4. So negative 6 is equals to 7 plus 4 is equals to 11x. Okay, now we need to get rid of that 11 that is multiplying my x. So I divide by 11. So my solution in this case is negative 6 over 11 equals to x. Or if you are someone like me that likes the x in the left side, or x is equals to negative 6 over 11. Any of those two solutions will be correct. Any of these forms, Alex will take it correct. It does not matter. It's just a matter of how you like it. Problem number 4, solve and graph the following inequality. Remember that now inequalities, we're going to have a set of solutions, and we need to graph that set of numbers. So I see parentheses first, distributive property. So I'm going to multiply 6 times 2 and 6 times 7. So I'm going to have 4x plus 2 is greater than or equals to 6 times 2x is 12x. 6 times 7 is 42. Then we need to do something with the x's. So I'm going to, in this case, move this 12 to the left, because I want my, as I was mentioning, we move the x to the left. I'm going to do that step first. So I'm going to get rid of 12 minus 12x. Remember that we use the opposite number. Minus 12x. Get rid of 12 on the right. Now I do 4 minus 12 is equals to negative 8x plus 2 greater than or equals to 42. Okay, let's get rid of that 2 that is next to my variable x. Remember, we are solving for x. So I'm going to use the opposite, minus 2, minus 2. These 2 goes away. So I have negative 8x is greater than or equals to 40. And final, we are going to divide by negative 8. Divide by negative 8. I'm going to continue here. But remember, with inequalities, if we divide or multiply by a negative number, the inequality sign changes orientation. So in this case, it will be x is less than or equals to negative 5. 40 divided by negative 8 is equals to negative 5. The inequality changed orientation to less than or equals because we divided by a negative number. Now we're going to graph. If my variable is on the left side, then I just need to graph the number. It's going to be a solid dot at negative 5 because it's less than or equal is included. So it's a closed dot. And the inequality sign is telling me where the graph is going. So it's pointing to the left. So my graph goes to the left, and it makes sense. Which number is less than negative 5? Negative 4. Which number is less than negative 5? Negative 3. Negative 6, negative 7, negative 8. The bigger the negative is, the less value it becomes. Sorry for the beginning. So I have negative 4 here, negative 3. These two are greater than negative 5. So our answer is correct. Let's go to problem number 5. Problem number 5 in this case, you're going to solve by graphing. This is a review from Algebra 1 from last year. Remember, in this case, both equations or both functions are already solved for y. I don't have to do absolutely nothing except for function number 1, which is going to be my blue graph, and the second function is going to be my red graph. I need the slope of this x. I need the slope on this function. Remember, if you only have negative x, I'm going to have this one as y equals negative 1 over 1 x minus 2. So this is my slope, and this one is my y-intercept. That's where I'm going to start my graph. So I'm going to start at negative 2. I'm going down 1 unit because the slope is rise over run, but we cannot go up because my slope is negative. So I'm going down and then run to the right. So I go down 1 unit and to the right 1. And I'm going to graph these lines. This one is not going to be a perfect graph because the grid is not the best. So I have my first function graphed. As you can see, the graph is going down from left to right because your slope is negative. Okay, and it's nice negative, like the slope, good. Then I have plus 4, that's my function 2. I have the y-intercept, I'm going to start at 4, and then I'm going up 1 and to the right 2, up 1 and to the right 2. So I have my 2 points, and then I just draw this line. I need to move this paper so I can draw it. And I have this one goes through these 2 points. And the definition says, in a system of equations solved by graphing, wherever these 2 lines intersect each other is going to be your solution. Remember that your x point is going first, negative 4 in x, and 2 in y. Boom, solution. Okay, let's go to write the equation of the line in the slope-intercept form. That is perpendicular in a slope-intercept form. That means y equals mx plus b. That is perpendicular. Remember the definition of perpendicular that we went on class. m1 times m2 is equals to negative 1. 2y equals negative 2 over 3x plus 4 and passes through the point 2 and 10. Remember that this one is x, this one is y. Now my slope given is negative 2 over 3, and we mentioned in class that the opposite reciprocal of that slope is going to be your perpendicular, the slope of the perpendicular line. So m2, this is m1 because it's given first. So m2 is equals to the opposite. If this is negative, the opposite is positive. And the reciprocal means just flipping the fraction. So I have 3 over 2. And because we're going to use the slope-intercept form, I have y equals mx plus b. I know my y is 10. I know the slope is 3 over 2. I know the value of x is 2 plus b. I need to find the y-intercept. B is the y-intercept. So 3 halves times 2. The 2 goes away because this is in the denominator. So I have 10 equals to 3 plus b. Let's get rid of that 3 because it's next to the b. So minus 3 minus 3. These 2 goes away. 10 minus 3 is 7 equals to b. Okay, that's the y-intercept. Now I'm ready to write the equation. Remember they one in slope-intercept form, mx plus b. I know the m is 3 over 2. So y is equals 3 over 2 x plus 7. And this is the solution to that problem. As we mentioned in class the other day, I said this is using technology. I'm going to do a whole lesson on this one, how to use the graphing calculator or even Desmos. So I'm not going to solve the problem, but I'm going to give the solution to this problem. This one, after you use the graphing calculator, you're going to have y equals 1.93x plus 141.62, and use the equation to predict the amount of dogs in 2050. That means you're going to substitute this number in x and find the value of y. It will be 296. We are going to do a lesson on this, so that's the reason why I'm just rushing this problem. Don't worry about this problem. So we move to problem number 8. We solved a couple of these ones. Remember that I'm going to write this one 4, 5 and -2, -4. I have x1, y1, x2, y2. The formula of the slope is m equals y2 minus y1 over x2 minus x1. So let's make the substitution. So this is equals to y2 is -4 minus from the formula, and this case is 5, and then I have x2 is -2 minus from the formula, and then I have 4. Okay, let's add. You have two negative numbers, we add them. -4 minus 5 is -9. -2 minus 4 is -6. Negative and negative is positive, so I have 9 over 6. We can simplify. 9 divided by 3, both are divisible by 3, which is 3 over 2. So my slope is equals 3 over 2. That's the solution to this problem. Okay, let's go to problem number 9. Let me change the paper. So we're going to graph now the following inequality. Remember that to graph inequalities is exactly the same as solving equations. It's exactly the same as solving our graphing functions. The only difference right now is just this inequality sign, but treat that inequality sign as an equal sign. Think of this one as an equal sign. So I need my y alone. So I need to cover my y. So I'm going to do -6 minus 6. Okay, this 6 goes away. So I have -2y is less than 4x minus 6. Now I'm going to divide by -2. Let's divide by -2, divide by -2, divide by -2. So these 2 goes away, -2. Then I have y. If we divide or multiply by a negative number, the inequality signs changes direction. So I have y is greater than or equal, greater than 4 divided by -2 is -2 x. -6 divided by -2 is positive 3. Okay, so that's my function. Remember, this is your slope and this is your y intercept. That's where we're going to start. I'm going to start at 3. The slope is negative. That means I'm going to go 2 units down and 1 to the right, because you can assume that you have 1 in the denominator. So I'm going 2 units down and 1 to the right. Now remember, when you graph inequalities, the inequality sign means lot. If it's only greater than, that means you're going to have a dashed line, because those points in the line are not going to be included. So I'm just going to graph a dashed line because it's not equal, so it's not a solid line. And the rule goes, if the inequality sign is greater, your solution is above, all the numbers above the line. And if you have less, it's all the numbers below the line. Now, for example, really fast. If I choose the point 0, 0, and I put 0 is greater than question mark, because I don't know, I'm just proving, -2 times 0 plus 3. So 0 is greater than -2 times 0 is 0, 3. It says 0 is greater than 3. That's not true. So that means all the values below the line are not solution, so have to be above the line. So every point that you choose above the line is going to be solution to that function. Now number 10, we went over this one in class also. So the main are all the values in x. So I have 1, 3, 6, 4, 7, and 2. Close bracket. Now we're going to range with all the values in y. So I have 5, 7, 3, 9, 0. Close bracket. We do not repeat values. I have 7 and 7. So I'm not going to write it again because it's already here. Now the question is that relation a function? So in this case, I'm going to look into my x values or domain and see if there is any repetition. I don't care about the y values. So x, 1, 3, 6, 4, 7, 2. There are no repetitions. So yes, it is a function. So that's the solution to that problem. Okay, let's go over number 11. We're going to graph that absolute value function. So remember what we mentioned in class. First, we're going to find the vertex. So the vertex is the x comma y. The x value is coming from inside the absolute value. So remember what I did in class was just to do x minus 3 is equals to 0, so x is equals to 3. So that's going to be your first value. I usually said is the opposite of the number inside the absolute value. And then your y value is coming from this number, 4, positive 4. So that's your vertex. That's where we're going to start. So the vertex is 3 and 4. So I go 3 in x, this is y. So 3 in x, 4 in y, so it's here. That's where your graph is going to start. Now I'm going to do a small table where I'm going to find the values of x and y. Now let's keep an eye that the absolute value function, when you graph it, is a v or inverted v. But in this case, because it's negative, that 1/2 is negative, the absolute value is going to open down. It's going down the graph. So this is your vertex, and then I'm going to choose a point between these numbers. So I'm going to say, I'm going to choose 1. I'm just deciding to use 1. So I'm going to use 1. So I have here, let's go back here. 1 minus 3 is negative 2. Absolute value of negative 2 is 2. 2 times negative 1/2 is negative 1. And 4 minus 1 is 3. So my point here is 1 and 3. And the next one, I'm going to do another one. Now look at this one. This is your vertex, right? That's where the graph is going to split in equal size. So if I have 2 units from the vertex, 1 to the other point goes here. So if I use 5, if I choose 5, 5 minus 3 is 2. Absolute value of 2 is 2. 2 times negative 1/2 is negative 1. 4 minus 1 is 3. It's the same point. So it will be 5 and 3. So that reason why I use the vertex, because the vertex cuts the graph in equal size. Okay, let me choose another one. I'm going to negative 1. I'm not going to use 0. I'm going to use negative 1. Negative 1. Negative 1 minus 3 is negative 4. Absolute value of negative 4 is positive 4. 4 times negative 1/2 is like saying 4 divided by 2 is negative 2. And 4 minus 2 is equals to 2. So my next point is negative 1 and 2. And look at this one. 1, 2, 3, 4. This is the vertex. 1, 2, 3, 4. That's my other point. So 7 and negative and 2. So now I'm going to graph. We're going to graph this function. So it goes down and it goes the same direction on the other side. So this is your absolute value graph for this problem. I think we did this one in class. Okay, let's go to problem number 12. It says, given the points 5 and negative 2 and a slope 3, write the equation of the line in a slope-intercept form. So remember, 5 comma negative 2 is x comma y. Then I have a slope equals 3. I'm going to use a slope intercept form. So y is -2, m is 3 times 5, which is x, plus b. 3 times 5 is 15, plus b. Let's get rid of that 15, minus 15, minus 15. These two goes away. So -17 is equals to b. Okay? Remember, we need to give that function or write the equation in a slope intercept form. So y is equals to, the slope is 3, so I have 3x minus 17. That's the solution. Okay, now we're going to solve the absolute value equation. It's an equation. I see an equal sign. Absolute values are not the same as parentheses, so we need to leave the absolute value alone. So I need to move that 4. So plus 4, these two goes away. So I have absolute value of x minus 3 equals to 7. Remember that an absolute value equation, we split it in two parts, one positive and one negative, because if we do the absolute value of a number, we have two outcomes, one positive and one negative. So I'm going to have positive side and a negative side. So the absolute value bars disappear. So I have x minus 3 equals to 7 and x minus 3 equals to -7. Now solve for x. So plus 3, plus, I'm going to do this one, plus 3. So these two goes away, so x is equals to 10. And here, these two goes away, so x is equals to -4, because the negative number is bigger than the positive number. So my solution is negative. Solve and graph. So I have a compound inequality. Now, if I have this style of compound inequalities, it's an AND inequality, because I have 2x less than or equals to x minus 4 and x minus 4 is less than or equals to 6. So I'm going to split in, like, for example, this is my first inequality and this is my second inequality. So I have 2x is less than or equals to x minus 4 and x minus 4 is less than or equals to 6. Let's solve. Now 2x is on the left, so I'm moving this x to the left. So I have minus x. These two x's goes away, so 2 minus 1 is 1. So x is less than or equals to -4. And so I have plus 4. These two goes away. X is less than or equals to 10. Now I need to graph. And because I have two inequalities, I'm going to do two graph before I do my final graph. So I have 0 here. The first inequality is at -4, close, and goes to the left. And then I have 10, also close, because it's less than or equal, and also goes to the left, because the inequality is less than or equal and is an AND inequality. I'm looking for where the intersection happens, and it happens at -4 to the left. So all this one is where the graph intercept each other. So my solution is, I have 10 here and I have -4 here. So my graph, or final graph, my solution starts at -4 to the left. Okay. Solve the system of equations using substitution or elimination. This one is also part of Algebra 1. I'm going to use substitution. Why? Because I have the x alone. My x is alone, so it's perfect to make the substitution. So I take the second equation, -3x minus 10y equals to 3, and make the substitution of this value into your x, because it's saying that x is equals to 14 minus 5y. So I have negative 3 times 14 minus 5y, close parenthesis, minus 10y equals to 3. Apply distributive property. So negative 3 times 14 is negative 42. Negative 42. Negative 3 times negative 5 is positive 15. Positive 15y minus 10y equals to 3. These two, they are like terms. So we can combine like terms. So 15 minus 10 is 5. Negative 42 plus 5y is equals to 3. Let's get rid of this 42. 42 is negative, so I'm going to use the opposite. So plus 42 plus 42. These two goes away. So 5y is equals to 45. Then we divide by 5. So I'm going to continue here. I have that y is equals to 9. Knowing that y is equals to 9, I need the value of x. So I take my first equation, because this is where x is already solved. X is alone. So x is equals to 14 minus 5y. So I'm going to make substitution again. So this is equals to 14 minus 5 times 9, because now I know that the value of y is 9. So equals to 14 minus 5 times 9, in this case is 45, negative. And then I have that x is equals to 14 minus 45 is equals to negative 31. So I'm ready to give my solution. Is parenthesis negative 31 comma 9. What that means, if you graph these two lines, this point is where the two lines intersect each other. So if you graph it on Desmos, Desmos is the easiest thing to do. If you plug in these two functions, you're going to see that those two lines intersect at this point. So that's the reason why this is your solution. Solve for f. We are going to solve for the variable f. See, this is where f is. What I see first is this 5 over 9 here. I'm not going to apply distributive property, because I'm not, as they said over there, I'm not going to get in shenanigans with fractions. I just need to move the fraction to the left side. So what I'm going to do is multiply 5 over 9 times c. 9 over 5. It's 9 over 5 because we're going to use the reciprocal of that number. It's 9 over 5. Okay. And this is equals to, look at this one, 9 over 5 times 5 over 9. Then I have f minus 32. Now in this case, these two goes away. Bye-bye. So I have 9 over 5c is equals to f minus 32. This is something that we can do. Cover your variable, get rid of 32. So plus 32 plus 32. We cannot combine these two because they are not like terms. So this 32 goes away. So 9 over 5 c plus 32 equals to f. So that's your solution. And this is the formula to convert Celsius degrees to from Fahrenheit to Celsius degrees. Now you're going to convert from Celsius degree to Fahrenheit. You're going to use that one when you go to Latin America and you want to know the weather, because all the weather in the rest of the world except the United States is in Celsius degrees. Okay, final problem number 17. What we have here is a system of equations. You have a value of x, you have y1 and y2. That means you have two graphs. And where the two y's have the same value, that's where your solution is. So I'm checking these numbers, this one, this one, this one, and then I see that y1 and y2 are the same at 4. So that's where your solution is going to be. See, these two y's are the same. So your solution is going to be negative 2 in x and 4 in y. So it doesn't matter if y1 and y2 are the same. That's your solution, 4. So that's it, as simple as that. So thank you very much. Hope you control the weekly review, and I will see you in class.